Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. My dear students and viewers, Yasin Ahmad Minai here. In continuation from the estimation topic we are discussing, and which is in continuation, now it is the time to have some study about the second type of interval, the estimators, sorry. Second type of estimator, which are said to be the interval estimators. Okay. So from the very beginning, I am taking my start from the confidence interval, which is about to assess the population mean mu. Now, since I am having a small derivation in this case, that's why I am taking my start from the population mean mu. So, how we could start? So, using the concept of the central limit theorem, let me show you the sketch in the form of illustration. This is the sketch of a standard normal curve. And right now I am highlighting tail areas of this standard normal curve with blue color. And since it is a standard normal curve, that's why in the middle it should be 0. The mean would be 0. And right now I am not providing you any value of these captured areas present in the left and the right tail. But I am representing these areas using a symbol, a Greek letter, which is alpha. So both ends are covered by a tiny area, which is represented by alpha by 2 on both sides, since both areas are the same. So if alpha by 2 and alpha by 2 are being allocated on either side of this curve, so what should be the area in the middle? Since the total area is 1, that's why this white area would be 1 minus alpha by 2 minus alpha by 2, which is nothing but 1 minus alpha. And how we could find the quantile present in this position on the left tail and on the right tail? One thing is understood. Okay, both quantiles will be same of magnitude but different in sign. Okay, so this left hand side quantile will be negative and the right hand side quantile will be positive. So since we do not have any value of alpha by 2 and alpha by 2, so eventually we are going to represent the quantiles in terms of symbol as well. So I am giving the symbol to the left side quantile, which is minus z alpha by 2. And similarly, the right hand side quantile will be the equal in magnitude but different in sign, which is positive z alpha by 2. And this whole situation presented in the graph can be written in the form of probability like this. Now minus z alpha by 2 up to plus z alpha by 2, and the captured area between these two quantiles are shown in the picture as well, which is nothing but 1 minus alpha. The similar illustration can be shown empirically as well. So it would be more easy for us if we are playing with numbers. So I am going to present the same illustration in the form of numbers. Okay, so both ends are being covered by a tiny area, which is nothing but 0.025, 0.025. And if you do remember how we can find the quantiles for given area in my previous lecture, you can easily deduce that this value must be minus 1.96 and the other one must be plus 1.96, and the area captured in the middle in the white uh, area, the white area is 0.95. So again, the same situation can be written in the form of probability like this. So now it would be more easily. Since we are dealing with a derivation, that's why we have to consider the same illustration I have shown in the previous slide, which was that one. Okay, and this is the probability. Now all we are interested is this inequality, this bound which is present inside the probability symbol. So I am taking it outside from the probability sign. Now we are having an interval, and using the concept of recalling the concept of central limit theorem. Z is a transformation which can be written like x minus mu upon sigma, but according to the central limit theorem, this transformation can be written like x bar minus mu divided by sigma over root n. So here it is. Now our work has been started just from here, and we have to solve this inequality, this interval for mu, because we want the confidence interval for population mean mu. That's why we have to solve it for mu. So first thing first. So this uh, sigma over root n, which is written in the denominator, must be vanished in the first step. So how we can vanish it? Yes, obviously we have to multiply sigma over root n throughout the inequality, so that we can eliminate this from the bottom of the center. So if we multiply this inequality throughout with sigma over root n, we can get this form like this, and this sigma over root n and sigma over root n will be cancel out, and then we can get like this. Okay, so again in the middle it is x bar minus mu, so we have to solve it since we are on the solution to find mu in the middle. That's why we have to vanish this x bar. So how we can eliminate x bar? Yes, we have to subtract x bar throughout the inequality or from both sides, and subtracting x bar from both sides, we can have this form. X bar has been subtracted on both sides, okay, and it is also been subtracted in the middle. So x bar and x bar will be cancelled out, and finally we got this picture. And since our mission is to find the value of mu, right, it is written minus mu. So how we can get rid of this minus sign? Yes, we can multiply this whole interval with minus 1. So multiplying the whole interval with minus 1 will actually remove the minus sign from the middle, but there will be a change in this particular inequality. It is about the direction of inequality. Firstly, it was less than equals to on both sides, but after multiplying it with minus 1, it is a property of inequality, then the whole interval is being converted into greater than equals to. Why it is like this? So the answer of this change in direction uh, can be presented by a corollary. And what is that corollary? If 5, 4 can be less than 5, right? We can write 4 is less than 5, but if you multiply both sides with minus 1, then it will become minus 4, and minus 4 is obviously greater than minus 5. So again, how we can convert it again into less than equals to? We cannot multiply it again with minus 1, because it will result in minus mu in the middle. That's why we can change the direction of inequalities. We can replace both sides. The side which is present on the right hand side can be moved towards the left hand side, and left hand side towards the right hand side, and finally this is our 1 minus alpha into 100% confidence interval for mu. And by putting any value of alpha which is prescribed by the researchers, we can have the confidence interval with a known quantile. So how we can find the value of alpha? Since I have also shown you the illustration, but if anyone want to use the steps for calculation, so for those uh, I am showing this. Alpha is equals to 0.05, then 1 minus alpha will be 0.95, and alpha by 2 will be 0.05. Okay, so alpha by 2 is 0.05, and z 0.05 is nothing but plus minus 1.96. So both ended quantiles are being calculated, and this will give us 95% confidence interval for the mean population mean mu. Now, after doing this, we are now in the position to solve some confidence interval. So for this purpose, we need some case. We need any case. And right now, I am giving you a case which is about the same grocery store owner, which has who has collected his profit for 1 month. So in 30 days, he observed his profit. Uh, the average profit was 6,400 rupees, and standard deviation generated in the reading of profit is around 1,200 rupees. And now he want to be assured that what is the 95% confidence interval for his average profit. Earlier, I stated 6,400 is equals to mu, but that wasn't mu, that was x bar. Since the sample is bigger, the sample size is 30, that's why I wrote mu in central limit theorem exercise. But actually, it is x bar. So we have the value of x bar, we have the value of sigma, we have the value of n, and the quantiles are known. So it is easy for us to proceed for the calculations of confidence interval for population mean mu. So how we can do it? Let me show you the calculation. We just replace all the relevant values in the formula of confidence interval 6400 minus 1.96 times 1200 upon root 30 less than equals to mu less than equals to 6400 plus 1.96 times 1200 divided by root 30, and it gives us answer 5970.6 less than equals to mu less than equals to 6829.4. So what does it mean? It is showing that with 95% confidence interval, he can say that his average profit will be lying within this range. Or if he performs some repeated samples, like if he collected 100 samples by repeated sampling time to time, then 95% sample means of his samples will be lying within this range, and approximately 5 mean will be lying outside from this range. So right now, the calculations for confidence interval for mu has been completed, and also the derivation has been completed. So in the next part, I will proceed for further confidence interval for other population parameters as well. So we will meet in the next video.